In this tutorial, I'm going to find the incidence matrix of the graph which is appearing on the left there. So for us to find that incidence matrix, I'll start by looking at the definition of the incidence matrix. The incidence matrix is an n by m matrix D, which has elements dij, where the dij is equals to 1 if vi is an end vertex of the edge ej and 0 otherwise. So what we would have there, the n will be the number of vertices that we have, the m, and the number of edges that we have. So in this case, we are having 6 vertices, v1 up to v6. So that will be our rows. So we have v1, v2, v3, v4, v5, and v6. And for our columns, the m's, we are having our m there is an 8 because we are having 8 edges. So we have my E1, E2, E3, E4, E5, E6, E7, E8, and those are all the edges that we are having there. So that will help us in writing the matrix that we want. So we now go on and look at vertices. And I'll start with vertex number 1. For vertex number 1, it is an end vertex of edges E4, E6, and E7. And by that definition, which is above, the dij there should be a 1, where we have the V1 being an end vertex of those edges. So what I will do is on the edges where we have E4, E6 and E7, I'll put the 1s on the matrix there. So we have a 1 on E4, E6, and E7. And it's saying 0 otherwise. So I'll put the 0s. And we are done with the first row of the incidence matrix. We now go on to vertex number 2 so that we look at the second row. Vertex number 2 there is an end vertex for edges E5, E6, and E8. So in our matrix where we have E5, E6, and E8, I'll put 1s there. And the definition it says 0 otherwise because it doesn't have the other edges. So put 0s. And we are done with the second row of our incidence matrix. We go on to the third row where we are now looking at vertex number 3. Vertex number 3 is an end vertex for edge 8 only. So it will have a 1 where we have the E8 there and 0 otherwise. So we are done with vertex number 3. We now move on to vertex number 4, which will give us our row 4. So looking at the graph there, the vertex 4 is an end vertex of the edges E2. It has E1, E2, E3, E5, and E7. So in our matrix there, where we have E1, E2, E3, E5, and E7, we put 1s there. So we have 1s on E1, E2, E3, E5, and E7. And the definition says 0 otherwise. So all the other elements, we put them 0s. We now move on to the fifth row. We are looking at vertex V5. So on the graph there, vertex V5, we see it is the end vertex of edges E3 and E4. And by that definition, our matrix would have 1s where we have E3 and E4. I put those 1s there. Where we have E3 and E4, then the definition says 0 otherwise. So all the other elements, I'll put them as 0s. And we are done with row number 5. We go on to the last row, and we are now looking at vertex number 6. Vertex number 6 is the end vertex of edges E1 and E2. So we have 1s where we have E1 and E2. So I put the 1s there on E1 and E2 and 0 otherwise. So for all the other elements in that row, we would have 0s. So I wrote those V1s up to V6 and E1 up to E8 just to enable us to write the matrix. So we have now obtained the matrix, so I can get rid of those V1 up to V6 and E1 up to E8, and I'll be left with that matrix there, which has 6 rows and 8 columns.